Hi everyone, welcome back to Tech-Bimba channel. In a previous video, I have talked about a multitasking. In this video, I will be talking about a multithreading. Thread is defined as an execution unit in the program. Let's see this with an example. In this example, we can see there is a class with a name sequential demo. In this class, we are having a public static void main. Here we are having a task 1 and task 2. Task 1 printing the value of I starting from 1 to 5. In a console we are printing task 1 hyphen count, then value of I, then we are printing the name of the thread that is running this task 1. Thread dot current thread dot get name prints the current thread name. Task 2 as well prints the value of I starting from 1 to 5. Here as well in a console we are printing task 2 hyphen count, then value of I, then the thread actually running this task 2. Once we execute this program, we will be getting the output something like this. Task 1 hyphen count, then value of I is 1 here. Thread name is a main. Task 1 hyphen count, now value of I is incremented to 2. Thread name is main here. So once the value of I is greater than 5, right, this loop breaks. This will begin. Task 2 hyphen 1 hyphen count 1 value of a thread name is main here, then task 2 hyphen count value of I is 2, it is executed by main thread. So once the value of I is greater than 6, right, this loop as well breaks, then main method terminates. So sequential demo.java is a program, right? Once we compile, sequential demo.class will be generated. It's nothing but a bytecode. On executing this one, use the command Java sequential demo process will be created. Since it's a Java program, Java instance will be created. Java instance figures out what is the starting point of this program. It finds out that public static void main is the starting point. At this time, main thread will be created. That is the reason we can see here name of the thread as a main here. Once main thread is created, all the instructions within this main method will be executed in sequence. That is the reason first task 1 is executed, then task 2 is executed. So sequential demo.java is our program. Within this program we are having a public static void main. Within this one we are having a task 1 and task 2. This task 1 and task 2 is nothing but a unit of a code. This unit of a code has the capability to execute, right? This is what we call it as a thread. Now coming back to the definition of a thread, right? So thread is defined as the smallest unit of execution in our program. Sequential demo.java is our program. Within this program, right, this is the smallest unit of execution. This unit of a code has the capability to execute. That's what we call it as a thread. Having said that, here in this case we are having only one thread, that is main thread, that is created by the Java instance itself. So in a main thread or in a main method, we can create n number of threads. That's what we call it as a multi-threaded program. In this example, we can see that we are having a class with a name multi-thread demo. Here we are having a public static void main. Here we are creating an instance of a thread with a name task 1 and a task 2. So don't worry about this. What is this new thread and lambda expression? I'll be covering that in detail in a next video. So as of now, just notice that this block of a code I moved here. This block of a code I moved as a part of a second thread, right? Then I am basically starting these two threads, task 1 dot start, task 2 dot start. Okay. So this task 1 is responsible for running this code. This task 2 is responsible for running this code, right? Then in a main thread also I'm having the loop, right? Here as well I'm printing the value of I starting from 1 to 5, and in the console I'm printing count, then main task, then value of I, and it is executed by which thread, right? So here what I'm doing is from the main thread I'm creating a two threads, task 1 and task 2, and then I'm starting those threads like task 1 dot start. Once I do task 1 dot start, right, this block of a code start executes. Once I do task 2 dot start, right, this block of a code will start executing. So once we execute this program, the output will be something like this. So here you can see task 1 hyphen count, then value of I is 1 here, it is executed by task 1 thread. Then task 2 hyphen count, value of I is 1 here, it is executed by task 2 thread. Then main task hyphen count, value of I is 1 here, it is executed by main thread. So if you notice here, this task 1 hyphen count 1 is coming from this block of a code. The second line task 2 hyphen count 1, it is executed by thread, is coming from this block of a code, whereas the third statement main task is coming from this block of a code, which means all the threads are executing independently, right? So what happens once I basically compile and run this code is, so once we compile, dot class will be generated. Once we execute this one, then process will be created. Since it's a Java program, Java instance will be created. Java instance figures out public static void main is the starting point. At this time main thread will be created. So just in time compiler it comes into picture. It figures out that within the main thread we are creating a 2 more threads, that is task 1 and task 2. So 2 more threads will be created. Once I do task 1 dot start and task 2 dot start, right, these threads will start executing the assigned code of the assigned block of a code. So task 1 will execute this block of a code, task 2 will start executing this block of a code. So whatever the output we are seeing here is like it's always not guaranteed. Sometimes we can see that task 2 gets a priority and it will be executed, sometimes main task, sometimes task 1. So it's entirely depends on the thread scheduler. So thread scheduler is the one basically that will hand over the thread to the CPU to execute. So whatever the thread CPU will get, that will be executed by the CPU. So this output is not guaranteed. It means in a multi-threaded environment, right, which thread will be invoked or which thread will be executed is not deterministic in nature, right? So in a multi-threaded environment we can define a thread as it's a unit of a code that have the capability to run independently, right? So hope this is clear what is thread and what is multi-threaded program. Now to give a real world example of multi-threaded environment or multi-threaded program, right, if you see this diagram, right, we are having a restaurant manager and here we are having a chef A, chef B, chef C and chef D. Even before looking into this, right, let's talk about the problem statement here. Say suppose we are having a restaurant and we are serving pizza, burger, cold coffee and a french fries. Since we are having only one chef, once the order comes, once the customer places the order, this only one guy has to prepare all kind of a dishes, which will be taking a more time. Okay, so we are not going to deliver the items in time, right? To solve this, what this restaurant manager did is he hired a 4 chef. Chef A, Chef B, Chef C and Chef D. Chef A is expert in preparing a pizza, Chef B is expert in preparing a burger, Chef C is expert in preparing a cold coffee and Chef D is responsible for preparing a french fries. So now with this setup, once the order arrives, this main program or a restaurant manager checks that order, and depending on the order, say suppose order is only for a pizza and burger, he will ask Chef A and Chef B to prepare pizza and burger, right? Chef A basically prepares the pizza, Chef B prepares burger. So in this case, Chef A is not required to wait for Chef B to complete the burger. Both can prepare the assigned dishes parallelly. Okay, say suppose order arrives for pizza, burger, cold coffee and french fries. Then this restaurant manager basically asks all the chefs to prepare the assigned dishes to them. With this, all the chefs independently prepare the assigned dishes to them, then hand over that dishes to the main programmer. Then main program basically or a restaurant manager delivers that order. So with this one we are increasing the response time. Within the limited amount of a time we are able to serve the customer. So this is the main advantage of a multi-threaded environment or multi-threaded programming. Let's say we are having a program with a name myapp.java. Here, right, in this program in a main thread we are creating a 2 threads and we are running this program in a 2 consoles. Since we are running this program in a 2 consoles, 2 processes are created. So in a previous video we have discussed that running instance of the program is nothing but a process. That is the reason here we can see two processes are created. So for these two processes, OS allocated the resources. We can see here from the physical memory, heap memory is allocated for each process. So in our last video, we have seen that two processes won't share the resources. They run independently. Since it's a Java program, right, JVM instance is created. Within this JVM instance, we can see there are different memory segments: heap memory, code segment, data segment, register, stack, counter. So within this process, there are three threads. Thread 1 is nothing but a main thread. Inside the main thread, we are creating two more threads, that is thread 2 and thread 3. All these three threads sharing heap memory, code segment and data segment, whereas stack, register, counter are unique for each thread. I mean, each thread has its own copy of register, stack and counter. So heap memory is allocated from the physical memory. So how much heap memory is allocated for each process depends on the JVM version, OS, system architecture, right? If you want, we can control that. So there are parameters like -XMS 256M. It means initial heap memory required is 256 MB. Then it can go up to how much? That we can specify with a -XMX 2G. It means initial heap memory is 256 MB and it can grow up to 2 GB. Once this 2 GB is exceeded, right, then we'll be getting a out of memory error. Now coming back to these memory segments, right, heap memory is used to basically create the objects. What are the objects we have created, right? All those objects will be stored here. Code segment, once we run, even before running, right, we will compile our program, right? Then bytecode will be generated. That bytecode is the one we are going to execute. That bytecode will be stored in this code segment. Data segments will be having a global or a static variables. So heap memory, code segment and data segments are shared by these three threads. Okay, then we are having a stack. Stack is unique per thread. I mean, each thread has its own stack copy, so it will be having a local variables and a method calls of these threads. Okay, then we are having a counter. This counter will be holding the offset of the instruction to be executed. So in this example, if you see here, since the thread is not yet started, it's not in a running state, at this time this thread will be holding the offset of this for loop. I mean, this is the instruction that it needs to execute next. So similarly, task 2 dot start, I mean, it's not yet started, so it will be holding this offset. So this is the instruction address that it needs to execute. Okay, so then we are having a register. Register is used to store the intermediate results. We will see these components, how they work to achieve the multi-threading. Okay, let's say we are having a program. This program is nothing but a set of instructions. So this program has a main method, and within that main method there are instructions. Then at some point we are creating a two threads. So this program will be sitting in our disk. So till this point it don't have any relevance. Once we want to execute this program, what we will do, we'll do Java, then we provide our program name, that is our bytecode, that is dot class of our program we will provide. Then process will be created. Since it's a Java program, JVM instance will be created. Then just in time compiler will finds out what is the starting point of our program. It figures out that public static void main is the starting point. At this time main thread will be created. It comes to know that in turn we are creating a two more threads. That time two more threads will be created, and required resources like a register, stack, program counter will be created for each thread. So at this point we can say our program is ready to execute. So then our program will be loaded from disk to RAM, right? So in the RAM already there are a list of processes. Our process will also come and it will sit in this queue. OS scheduler is the one that will basically allocate a CPU to execute any of the process that we have discussed in our previous video. Say suppose CPU scheduler picks up our process. So since in our process there are more than one thread, right? So internally it maintains a one thread table. Here it will be having a thread name with their priority. So we have seen that thread is nothing but a unit of a code that has the capability to execute that code independently. So now CPU scheduler has to decide which thread it has to pick and execute that one. That is the reason we are maintaining a thread table here and with a priority. Say suppose thread scheduler or a CPU scheduler picked up this thread, okay, it will be handed over to CPU to execute. This thread scheduler will be having a program counter. That program counter will be pointing to the instruction that's supposed to be executed, okay. With that, CPU will start executing those set of instructions. Say suppose our thread is having a 100 instructions, okay. Now initially it's the first time thread started executing and program counter will be pointing to the 0th instruction. So with that, CPU will start from 0th instruction. It executed up to 50th instruction. Now since allocated time for this thread is elapsed, okay, now it has to basically come and sit into the thread table again. That what we call it as a context switching. At this time, till now what all the computations CPU has done, right? CPU will be storing that result in a register. Now since a context switching about to happen, CPU will store the register value into the threads register, okay, and program counter will be now pointing to the 51st instruction. With that, thread will be sitting in our thread table. Now say suppose thread 2 get a chance. Thread 2 will be having a program counter. It will be pointing to the instruction that's it's supposed to be executed by the CPU. With that, CPU will start executing the thread 2's instruction. Say suppose again allocated time for this thread 2 is elapsed. Now again context switching will happen. Whatever the value it computed in a CPU register will be stored in a threads register, okay. Then program counter will be pointed to the next set of instruction it is supposed to execute when it again gets the CPU cycle. Now context switching will happen. Say suppose again thread 1 gets its chance. So now program counter is pointed to 51st instruction. Since the CPU is already executed up to 50 instructions, so it is pointed to 51st instruction. Using that, CPU is aware that it has executed till 50 instruction, it has to execute it next 51st instruction, right? Now whatever the value it has in the thread register, right, it will be stored back to the CPU register. With that, CPU will be aware that till what level computation it has done. Say suppose in our thread we have a problem statement, or it is going to solve like it has to compute up to 1 lakh numbers, right? Still now it has done the sum of 50,000. That will be stored in a thread and it will be given back to the CPU register, so that CPU will be aware that till now it has computed up to 50,000 numbers. That result will be stored back to the CPU and go from that it will take forward. I mean, it will start executing 51st instruction, and from 50,000 numbers it will add up again 50,000 plus 1 2 3, it will go on. So if again the context switching will happen, whatever the computation done on the CPU register will be stored back to the thread register, and program counter will be pointed to the next set of instruction. So like this, in case of a single CPU, single core, multi-threading will happen. So it appears like more than one threads are executing at the same time, but if you see at the nanosecond level, only one thread will be executed by the CPU. In case, say suppose in a modern computers there will be more than one CPU and more than a one core. In that case, if there are a number of threads that are less than number of a CPU or core, then actually multi-threading will happen. Each core or each CPU will run the threads independently. But in case number of threads are more than a number of a CPU or number of a cores, then using the context switching only multitasking will happen. So mainly multi-threading is used to basically to get the best utilization of the CPU. If you see this diagram, we are having a main thread. It will be running a set of instruction. Then to execute the next set of instruction, it has to read the data from the disk, right? At this time, mostly CPU is idle. So instead of waiting for the data to be read from the disk, right, here we can utilize the CPU by giving a chance to the thread 2 to execute. So thread 2 will come into picture, it will execute and it will finish its task. Since again main thread is still waiting for data to be read from the disk, then thread 3 will come into a picture, thread 3 will start executing. So it executed this point, then it has some dependency on a network, say suppose, so it will fetch data from the network. At that time again CPU is idle, so it will check whether main thread basically read the data from the disk and it is ready to execute. At this point, yes, so it will start executing main thread where it basically left over. So it completes the main thread, then it will check whether the thread 3 is now ready to be executed by the CPU. Yes, it at this point network call is completed, it got the required data, so it will start executing thread 3 again. So at this time again it has some dependency on the data from the disk, so again CPU will be idle for this much time. At this time, if you see here, main thread is also completed and thread 2 also completed. So at this time CPU will wait, right? So CPU will be idle at this time. So once it got the data from the disk, right, then only CPU will be able to complete this thread 3. So if you see here, using a multi-threaded environment or a multi-threading, we can get a best utilization of the CPU. So it's one of the advantage of the multi-threaded program. Next advantage is improved responsiveness. Say suppose we are having a UI where we need to upload the file and we need to do set of validations. So if you block the users for these validations or till this validation is completed, then it will lead to a bad user experience. To avoid that, what we can do is we can spawn one thread and we can assign that validations of the file in separate thread. Using that, we will make sure that user will not be stuck, so he'll be able to interact with the UI and he can able to do other tasks. Faster program execution. So since we are getting the best utilization of the CPU is not idle, the idle time is utilized by the other threads, so we can achieve the faster execution of the program. So resource sharing is the one more advantage. Since all the threads present in the process share the resources, so we can say that we can best utilize the process resources within the threads, right? Next, coming to the disadvantages, so it's a very complex to debugging. So since threads are all the threads are running in parallel, so we are not sure where the issue will occur, so it will be very difficult to debugging. Then context switching is overhead in case of more than one thread, so CPU has to basically do the context switching so that all the threads will get a chance to execute. That's the reason context switching is the overhead here. In case more than one threads are sharing the resources, then we need to take care of the synchronization, otherwise we will end up leading to the data inconsistency. So these threads are indeterministic in nature, so I already told, right? So if you run the same program again and again, it's not guaranteed that this output will be returned. So this is not deterministic, so it depends on the thread scheduler or a CPU scheduler to which thread CPU will get a chance, and depending on this output will be determined, so this will be not guaranteed. The last topic in this video is multi-threading versus multitasking. So multitasking is nothing but if more than one threads are if in case more than one process are executing, right? In case more than one process are executing, that what we call it as a multitasking. In case of a multitasking, resources are not shared among the processes, whereas a multi-threading, more than one threads are running within the process, so here all the threads share the processes resources. This is the main difference between a multitasking and a multi-threading. Okay, so this is the introduction video of multi-threading. So if you found this video helpful, please share, like and subscribe to this channel. See you in the next video. Thanks for watching.